you so much. Moving on the next lightning talk, we have Anuradha on the topic semiconductor industry. What is it and how to thrive in it? So once again, give it up for Anuradha. Thank you.
Good afternoon, everybody. So first of all, I would like to thank anita.org for giving me this opportunity to be a speaker and to speak about semiconductors here. I think this is the only session on semiconductors that's happening in this conference. So I'm Anu Dwarkanath. I'm an engineer, an MBA grad, and a PMP, and I mix all of them together in my current role, which is a technical program manager for Lam Research. So Lam is one of the semiconductor capital equipment manufacturers. So today's agenda, with a show of hands, I want to know how many of you are familiar with semiconductor industry here? Okay, not bad. 1/3 of the room. So this session is for refresher for the 1/3, and for the 2/3, it's more like a familiarity of what this industry is. You must have heard semiconductors is booming now, especially in India. So what is this industry? What do we do here? Who are the major players? What's the challenges? And for all those new entrants here, what kind of careers can you look for in this industry, right? That's what I want you to take back from this session. Okay, so my topic, I changed it from saying sand to chips. So that's, what does it mean, right? Sand to chips here is not the potato chips, but it's our integrated circuits or microchips that we call. So how does it make a journey from being sand to being a chip? That is what the whole semiconductor industry is about. So just to begin with, a little bit going back to your school, what is semiconductor? The name suggests it, right? It's a special kind of a material which can act both as a conductor and an insulator. It depends on certain conditions, it becomes either a conductor or an insulator. So silicon found in sand, which is found everywhere. Somebody was telling me, oh, you're going to take the beach to the chip. It is indeed like that, right? You take the sand and you take the silicon out of it and make a chip out of that. So now what happens to that sand? So that silicon now, when I said you add certain materials, it increases its conductivity. So those are called the dopants. We add chemical substances, could be copper, nickel, tin silver, there are other materials which you add, which increases its conductivity. And that's when it becomes the PN junction diode, right? Going back to engineering lessons again, the positive negative diode, which is the basic building block of our microchips. So now, microchips are made up of billions of these transistors, and they're pretty much found in any of the device that you have, you own, you wear. Any IoT devices, you will have a chip. That chip will have a transistor, and that is made out of semiconductors. So that is the journey from being a sand to a chip. How does that happen? So that is the next one. Let me go back one. So just to summarize, if anybody asks you what is semiconductors, one line is you take a thin slice of wafer, a silicon wafer, and then you build your circuit on it. That is what the semiconductor industry is really about. Now going on to wafer fabrication process. So what is this? So I said it goes from being sand to a chip. How does that work? So first thing is the silicon in sand will be extracted into silicon rods. Those are called silicon ingots. So you can see that there is a long rod. And then they're sliced into thin wafers. So that's why it's called the wafer fabrication. And after that, the circuit is built on that. Right now, it is just a semiconductor. You have to add those dopants for it to start conducting. So that is the next process. Okay, first one you do is, and I'm actually putting here an abridged version of a wafer fabrication process. There's going to be much more details which you can probably look up later. So first thing is we put an oxide layer on that to make sure there's no current leakage. And next will be, yeah, this is photolithography. So this is something like a stencil. So stencil and a pencil. If you take a paper and you want to draw a pattern, so you take a stencil and then you draw it out, right? That's exactly what we do here. We write the circuit design. There are many companies here who are into chip design. So that's where they make the design, and now you want to put the design on the wafer. So what, you first put a photoresist material, and then put the photomask or the stencil, and using light to kind of write the pattern on the wafer. So that's photolithography. So once now that you have your circuit on the wafer, you will want to remove all the unnecessary material so you can start doping it to make it a circuit or a conductor, right? That's etching. And Lam is one of the players, major players in this etching. Then comes adding the dopants. So this is called the metal deposition. Here is where you can add copper, tin, silver, tungsten. Yeah, so you can add these. This is where you give semiconductor its conducting property. Now with this, actually pretty much your circuit is done, but it's not this simple. It goes through an iterative process of, you stack circuits on circuits and circuits and circuits. So it goes through a lot of, I've simplified it a lot, but it goes through multiple stages like that. And okay, its last part is the polishing. So this is once your wafer is ready, you clean it, you polish it, and it's ready for consumption. And after that comes all those testing and packaging. So first one is the EDS. It's electron dispersive spectroscopy. It's like a QA, it's a quality, right? You see which chips are good, which are defective, and you take them out. And last one is the packaging. So this wafer you see at the very first one is actually, I think it has about 300 to 400 little integrated chips, ICs. So those have to be diced, and they have to be packaged. So that is what packaging is. It's called a substrate, where that black thing you see, where you should see that Intel inside black case. That's the substrate. So that's packed and finally released out for testing for various applications or appliances, wherever. Okay. Now, just to give you, now to give the industry overview, who are the key players? First one is the silicon wafer manufacturer. So those silicon ingots, there are a few industries. I'll move on. Now, the semiconductor capital equipment manufacturers. So these are now, whatever process I mentioned, there are companies who make tools for this process. So they are called the capital equipment manufacturers. And some of the names are put here. Lam Research, my own company, we are into etch and deposition products. Then Applied Materials, KLA, SML, TEL. Now, these are just to name a few, so these are not a limited list. And then comes what happens. Now, you got the sand, you got the chip. What happens to that chip? Or rather, sorry, you got the sand, you got the tools to make the chip, but what about the chip? That's where these three companies come into picture. So first one is the integrated device manufacturers. So these are the companies which own end-to-end end-to-end wafer fabrication, meaning they do the chip design. They also do the manufacturing of that. And note, these are all very heavy capital investment tools. So not every company wants to get into it on the manufacturing end. And on the other side, there are the pure play foundries and the fabless. So fabless are those who don't want to enter into the manufacturing world. They just do the chip design and hand it over to the pure play foundries who do not do any chip design. They are purely manufacturing. So now if I show you the companies, you will be able to relate to them. So now IDMs, Intel, Samsung, very common names, then Texas Instruments, SK Hynix, Micron. Again, these are just a limited list, these are not just them. Pure play foundries, TSMC is one of the biggest. In fact, Apple uses them. They're one of the biggest. I think Microsoft uses them, somebody told me. Okay, and then fabless, AMD, NVIDIA, there's an NVIDIA person here, and Qualcomm. So these are all doing chip designs. What are the challenges now, right? And this is a key I want all of you to understand, because challenges bring in opportunities. So if you're looking for entering into the semiconductor industry, this will be good. First thing is miniaturization, meaning the chart at the bottom shows how exponentially we have, so rather there is a need to pump in more transistors into one chip. So make the transistor smaller. There's Moore's law, if some of you are familiar with it. He says that every 2 years, you will reduce the size of the chip. So you pump in a lot more transistors into a chip. So what you do is you're exponentially increasing the power, the efficiency, computing power of the chip, and also exponentially decreasing the size. That's how you can see that your appliances are going smaller and smaller, right? But this also adds a lot of technical challenges that you have to imagine the fabrication you have to do on such miniaturized devices. And then supply chain disruption. So this came out heavily during COVID. So if I were to kind of categorize the manufacturing industry, semiconductor manufacturing industry, I'll say one is just the chip design, which predominantly runs in the US. And then there's a chip manufacturing, which predominantly runs in the Southeast Asia, mostly Taiwan, Korea, China, yeah, and that's assembly, testing, packaging, all those, everything other than chip design. Now what happened during COVID is I was in US at that time, and there was a major chip shortage to an extent that we didn't have cars from Tesla. Because Tesla completely runs on these chips, there were no chips. Why were there no chips? We could not bring anything out of these Southeast Asian countries, right? And that was a reality check for a lot of countries where they started seeing why semiconductors is so important. In fact, India is also now on to that I'll present it in just a minute. So this, and now adding to all the geopolitical volatility that's happened, the wars happening, this government, different elections, and natural disasters. So Taiwan went through this. There was a typhoon or something, and it really disrupted a lot of the supply chain. So that is the reason now it's every country wants to have their own fabrication. They don't want to depend on just one area to do that. Last one, but very important one, is it's a very niche, I was saying to Poonam, it's a very niche field. So which means there's a lack of skilled talent, but where there's a lack, there's also an opportunity. There's an opportunity to get into it, learn more, bring more women into this, I would feel. As such, manufacturing, the less women, bring more women into it. Okay, now what careers are we looking at? So categorize into three. So one is on the technical part. If it's not only software, or rather software is a smaller part here, but if you're mechanical, electrical, chemical, materials, so process, then hardware, firmware, a lot of scope in this field. And business process like I am in project management, process management, program management, product management. So I've been with Lam for about 13 years and I've held various roles in this vertical. I've held a lot of roles. And of course, if you're into business operations, we have those as well. And most important, why is this an important right now? Because Mr. Modi is really pushing semiconductors in India. And I don't think I heard this much a few years back. But now we have the India Semiconductor Mission, which is to bring in a fab is what I meant, the wafer fabrication, the huge labs where you see people in bunny suits, right? That's a fab. So there is going to be a fab in India. It's coming up by Tata Electronics. So where we'll do both wafer fabrication and testing, right? And we are sourcing it within our own country, so that you can imagine the kind of career you can have here. And also, very interesting, I met a person from a college here, and she said, oh, I know Lam Research because we are doing some training programs with their college. So the lack of skilled talent is noticed, and companies are coming forward. ISC, they're all coming forward to train them on this niche. Okay, so I think with that, I'm right on time. Yeah, and I want to just leave you with this, that it is a niche field, and India is riding a wave. So go ride it if you're interested. Okay? Thank you. You can connect with me on LinkedIn, or any questions, I'll be here. Thank you.
Thank you so much. To present a token of appreciation from my side, I call upon Poonam. Thank you so much for this amazing lightning talk.